Tonight, we're looking into posts being spread on social media. They claim the James Webb Space Telescope spotted a large object about 10 light years away moving toward Earth.
The more I look at the universe, just the less convinced I am that there is something benevolent going on.
Mysterious objects are racing toward Earth, forcing the United States government into high alert. The skies are alive with motion as scientists urgently work to uncover the dangers of these cosmic invaders. This is no far-off theory. The threats are real, and every second counts. Tune in as we unravel the chilling details, the efforts, and the devastating possibilities that could reshape life as we know it. Cosmic threats and survival tactics. Let's start with Bennu, a name that should already make your ears perk up. This asteroid, only about 500 meters across, has been a hot topic for a while now. It's not set to hit us anytime soon, but if it does in the 22nd century, it could be catastrophic. Scientists aren't just sitting around worrying, though. They sent out a mission, Osiris-REx, to scoop up some of Bennu's surface dirt and bring it back to Earth. Why? To figure out what makes this asteroid tick. Knowing its makeup and behavior can help us prepare for worst-case scenarios, like building tech to shove it off course or brace for impact. Even though the chances are low, the stakes are sky-high. Bennu hides a secret that could upend everything we know about near-Earth objects. Bennu isn't the only thing that has everyone sweating. Apophis is another asteroid that had people losing sleep back in the day. The good news? It's not going to slam into Earth anytime soon. The bad news? It'll still swing by disturbingly close in 2029. Scientists plan to use that chance to study it up close and personal, like giving a wild animal a wide berth but still taking notes. This is all part of the broader effort to track and understand near-Earth objects, NEOs. Better safe than sorry, right? Now, while asteroids are the headliners, don't forget about our sun. It's the giant ball of fire that keeps us alive. But it's also a ticking time bomb. Solar flares, basically explosions on the sun's surface, can cause geomagnetic storms here on Earth. These storms can mess with everything. Satellites, GPS, power grids, you name it. Back in 1989, one such storm knocked out power across Quebec, leaving millions in the dark. Imagine that happening today, when we're even more dependent on tech. It's no wonder that forecasting space weather has become a full-time gig. The goal is to spot these solar temper tantrums before they hit and minimize the damage. And let's not even start on rogue planets. Massive, wandering loners, kicked out of their star systems. These guys drift through space without a care in the universe. The chances of one of them crashing into us are beyond slim, but their mere existence is enough to keep astronomers up at night. If one got close enough, it could mess with our solar system's delicate balance. Planets might wobble out of their orbits, causing all kinds of chaos. These planets are mysterious, but they also make us wonder what else is out there. Could they even support life? Maybe, but don't expect them to be friendly neighbors. Rogue planets aren't just fascinating anomalies. They're reminders of how chaotic the cosmos really is. Imagine a world without a star, left to wander in eternal darkness. The temperatures on such planets are extreme, often plummeting to hundreds of degrees below freezing. Yet some scientists theorize that these planets might have subsurface oceans warmed by their own internal heat. Could life survive in such an environment? It's a question that keeps researchers awake at night. Even though the odds of a rogue planet crossing paths with Earth are tiny, the consequences of such an event would be catastrophic. Then there are black holes, the ultimate cosmic monsters. They're not actively hunting Earth, but their gravity is so intense that even light can't escape. If one wandered too close, it could disrupt the entire solar system, tossing planets and asteroids like toys. Luckily, the nearest supermassive black hole is far away and behaving itself. Still, the universe is full of rogue black holes, and who knows what one of those might do if it passed through our corner of space. Speaking of black holes, let's not forget the ones that lurk quietly in the background, far away yet still influencing their surroundings. Supermassive black holes are found at the centers of galaxies, including our own Milky Way. The one at the heart of our galaxy, Sagittarius A, is massive yet relatively calm. But what if it weren't? A more active black hole could send out jets of radiation that might affect life on Earth. The idea of a wandering black hole moving through our solar system might sound like pure science fiction, but the universe has a way of surprising us. It's better to understand these phenomena than to ignore them. With all this going on, it's easy to feel like Earth is just a target waiting to be hit. But the reality is more complicated. Scientists and engineers are working hard to understand these threats and come up with ways to protect us. Whether it's tracking asteroids, forecasting solar storms, or studying rogue planets, every bit of knowledge helps. For example, there's growing interest in developing planetary defense systems. These include technologies that could deflect an asteroid or even break it apart before it reaches Earth. Missions like NASA's Double Asteroid Redirection Test are paving the way for such innovations. The DART mission successfully altered the orbit of a small asteroid, proving that we can influence the movement of celestial objects. This is a crucial step in preparing for any future threats. Then there's the challenge of predicting and mitigating the effects of solar storms. Scientists use satellites to monitor the sun's activity and provide early warnings of geomagnetic storms. Governments and power companies are also investing in technologies to protect critical infrastructure, such as power grids, from the effects of these storms. While we can't stop solar flares from happening, we can reduce their impact on our daily lives. The study of rogue planets is another area where advancements are being made. Astronomers are using powerful telescopes to detect these wandering worlds and learn more about their characteristics. By understanding how rogue planets form and behave, scientists can refine their models of planetary systems and improve our knowledge of the universe. Who knows? We might even discover a rogue planet with conditions suitable for life, opening up new possibilities for exploration. Black holes, too, are being studied more closely than ever before. The Event Horizon Telescope, a network of telescopes around the globe, captured the first ever image of a black hole in 2019. This groundbreaking achievement has opened up new avenues for understanding these enigmatic objects. Scientists are now working to create more detailed images and gather data on how black holes interact with their surroundings. These efforts could help us better predict the behavior of black holes and their potential impact on Earth. Next, we look at a space rock getting uncomfortably close to Earth: cosmic fire drills. Let's talk about Apophis again for a moment. Discovered in the early 2000s, this chunk of rock is over 1,200 feet wide, roughly the size of 3 football fields placed end to end. If this bad boy were to hit Earth, it'd be like a city-destroying fireworks show nobody asked for. Luckily, scientists have assured us that Apophis won't smack into Earth when it swings by on April 13th, 2029. Still, it'll come uncomfortably close, closer than some of our satellites. Imagine looking up and seeing a glowing dot streak across the sky. That's Apophis, and it'll be a once-in-a-lifetime sight, hopefully without any catastrophic side effects. Here's the kicker, though. Even though we've dodged the 2029 bullet, Earth's gravity might tweak Apophis's orbit just enough to cause problems during its next close pass in 2036. This possibility has scientists on high alert, running simulations and prepping plans, because, let's face it, you don't want to gamble with something that could turn your favorite city into a crater. NASA has already started conducting asteroid preparedness drills. Think of these as cosmic fire drills, but with a lot more math and way higher stakes. One recent simulation threw a curveball: an imaginary asteroid, invisible until it was practically on Earth's doorstep, with only 6 months of warning. The result? A grim realization that we're not exactly ready to handle such a scenario. Current technology, like smashing a spacecraft into the asteroid to nudge it off course, needs years of prep time. And don't even get started on the logistics of international cooperation for something like this. This isn't just about Apophis. There are plenty of other asteroids whizzing around out there, and many are small enough to slip past our telescopes until they're almost here. Remember the Chelyabinsk meteor back in 2013? That rock was only about 60 feet wide, but it exploded over Russia with the force of multiple nuclear bombs. Windows shattered, thousands were injured, and the world got a sharp reminder of how vulnerable we are to cosmic surprises. Scientists are trying to improve our odds. NASA's Scout system, for example, recently tracked a tiny asteroid that burned up harmlessly over Germany. That success shows progress in monitoring these space rocks, but it's still a far cry from being ready for the big ones. International cooperation is also a must. An asteroid impact wouldn't just be one country's problem, It'd be a global disaster. But getting countries to agree on how to handle it is another story. The recent drills reveal gaps in communication, planning, and available technology. Now a look back at the collision that changed life on Earth forever. Are we ready for another strike? 66 million years ago, something massive hurtled through space and smashed into what is now Mexico's Yucatan Peninsula. The aftermath? A cataclysmic extinction event that wiped out 75% of life on Earth, including the dinosaurs. They had ruled the planet for over 100 million years. And then, just like that, their reign ended. It's a chilling thought. Could something like this happen again? Asteroids crashing into Earth isn't science fiction. It's a fact. Impact craters scattered across the globe are evidence of these cosmic collisions. Experts like Dr. David Kring, a planetary geologist, and Dr. Mark Boslow, a physicist, study these impacts to understand their scale and implications. For example, the Chicxulub crater, a massive depression buried beneath Mexico's Gulf Coast, is thought to be about 110 miles wide. It was created by an asteroid roughly 6 miles across. That's like a rock the size of a city slamming into Earth at mind-boggling speeds. What happens when an asteroid hits Earth? First, it tears through the atmosphere, heating up and vaporizing as it crashes. The Chicxulub asteroid, for instance, displaced massive amounts of air, creating a plasma that radiated heat and light. The result was an explosion so intense it rivaled temperatures found on the surface of the sun. Imagine rock and debris flying 60 miles into the air, 10 times the height of Mount Everest, before raining back down. Fires ignited across the globe and the skies choked with ash and dust. Then there's the water. A massive impact near an ocean triggers towering tsunamis. At Chicxulub, waves at least 300 feet high surged across the Gulf of Mexico, inundating what is now Texas and pushing inland. A wave of that scale would make skyscrapers look puny. Cities would be wiped off the map. The aftermath of an asteroid impact is nothing short of apocalyptic. The Chicxulub event ejected an estimated 10 trillion tons of debris into the atmosphere, blotting out the sun. Without sunlight, plants die, disrupting the food chain from the bottom up. Temperatures plummet, triggering an ice age. Earthquakes ripple through the crust, and the ground itself shakes violently. Buildings crumble, roads disappear, and life as we know it collapses. But what if this happened today? An asteroid only a few miles wide, a fraction of Chicxulub's size, could cause devastation on an unimaginable scale. A direct hit near a major city would flatten everything in a radius of hundreds of miles. The heat alone would vaporize life within seconds. Even smaller impacts, like an airburst, could incinerate a city or cause catastrophic damage. The scariest part? Earth gets hit by space rocks all the time. Most are tiny, just dust particles, and burn up harmlessly in the atmosphere. But larger objects, those a few meters wide or more, can reach the surface. Scientists estimate that Earth has been struck over 60 times by objects 3 miles wide or larger in the last 600 million years. And it's not a matter of if it will happen again. It's a matter of when. Efforts are underway to monitor potential threats. NASA and other organizations track asteroids, but the task is daunting. Some asteroids are nearly invisible, their dark surfaces blending with the void of space. Current plans for deflection, like ramming a spacecraft into an asteroid to change its trajectory, are still theoretical and require advanced warning. Without that, there's little humanity could do against a sudden plunge from space. The Chicxulub impact also reminds us of Earth's fragility. The sulfur-rich rocks in the region combine with the asteroid's sulfur content to create a toxic atmosphere. The gases lingered for decades, altering the climate and intensifying global warming. If a similar event occurred today, the greenhouse effects could last for centuries, worsening an already fragile ecosystem. A smaller asteroid, one a few hundred feet across, could still cause chaos. These are far more common and could destroy a city or cause widespread damage. With over 800,000 asteroids identified in our solar system, the odds of a significant collision are far from zero. The lesson is clear: Earth is vulnerable. Advanced technologies and space programs provide some hope, but humanity must prepare for the unpredictable. The vast crater at Chicxulub stands as a reminder of both our planet's violent history and our responsibility to protect its future. Whether it's through better detection systems, global cooperation, or innovative solutions, the clock is ticking. The next big impact might not be 66 million years away. To fully grasp the scale of devastation an asteroid impact could bring today, consider the implications beyond the immediate blast zone. The initial collision would unleash a kinetic energy measured in tens of millions of megatons. For context, the largest nuclear bombs ever detonated, like the Tsar Bomba, were measured in tens of megatons. An asteroid's force would dwarf these entirely. The thermal radiation alone could ignite fires thousands of miles away from the impact site, scorching forests, fields, and cities alike. The resulting shockwave would flatten buildings, uproot trees, and even alter local geography permanently. In addition to physical destruction, the secondary effects would be equally devastating. The vast quantities of dust and ash ejected into the atmosphere would create a nuclear winter scenario. Without sunlight, global agriculture would fail within weeks, leading to famine and societal collapse. Wildlife and marine ecosystems would be severely disrupted as food chains disintegrate. These cascading effects would make survival nearly impossible for most species. Tsunamis generated by an oceanic impact would devastate coastlines worldwide. Waves hundreds of feet high would crash ashore with incredible force, sweeping away entire cities and displacing millions of people. The psychological toll on survivors, combined with the logistical nightmare of providing aid and rebuilding, would stretch global resources beyond breaking point. The long-term climatic effects would linger for decades. Reduced sunlight from atmospheric debris would lead to colder temperatures, stalling photosynthesis, and creating a domino effect on the planet's ecosystems. Combined with toxic gases like sulfur dioxide, the Earth's atmosphere could shift dramatically, becoming less hospitable for humans and other forms of life. Asteroid impacts also have the potential to disrupt technological systems globally. Satellites in orbit could be damaged by debris, leading to communication breakdowns. Power grids and other critical infrastructure might fail due to the electromagnetic pulse generated by the impact. Modern civilization's dependence on interconnected systems would become a vulnerability in such a scenario. Given these possibilities, planetary defense is more critical than ever. Scientists and engineers are exploring a variety of methods to prevent or mitigate asteroid impacts. One proposed solution is the gravity tractor method, which involves sending a spacecraft to fly alongside an asteroid and gradually alter its trajectory using gravitational pull. Another concept involves deploying solar sails or attaching rocket engines to the asteroid to nudge it off course. These approaches require precise calculations and years of preparation, highlighting the importance of early detection. Public awareness and international cooperation will also play a vital role in planetary defense. Governments, scientific organizations, and private companies must work together to fund research and develop the necessary technologies. Education campaigns can help people understand the risks and prepare for potential emergencies. Investing in asteroid detection systems and response plans is not just a scientific endeavor, it's a matter of global survival. How much responsibility should humanity bear for its own survival, even against cosmic threats? Share your thoughts below and don't forget to like, comment, and subscribe.